Now, if you look at the global the problem of vitamin A deficiency, it's mostly the developing countries are affected by this, and especially the Southeast and South Asia, like India and other countries, we have more prominence of VAD. The common people who are affected by these deficiencies, mostly children, then pregnant women. The VAD leads to weakness of the immune system, and it also causes childbirth related deaths in women. And it affects mostly the poor who lack nutritious diets along with vitamin and other supplements. And also it contributes to anemia indirectly. If you see the deficiency of vitamin A, it leads to night blindness. Sometimes total blindness is observed, and growth retardation, reproductive disorders. There's a lot of other complications due to the vitamin A. If you look at the global scenario, 127 million preschool children are vitamin A deficient, and among them 2 to 3% of them die. Around 20 million pregnant women in developing countries are vitamin A deficient, almost 50 to 55% in India. Now, this being the enormity of the seriousness of the problem, what are the other options available? We have the food supplements in the form of vitamin A, vegetables, and then fruits, and as a staple food, we thought that the golden rice is one of the solutions for VAD. Now, what is golden rice? See, I'm just defining. Of course, not everybody knows, but for our farmers' friends, it's a genetically engineered rice which can produce and accumulate beta carotene, which is a provitamin A. It's a precursor for vitamin A that expresses in the endosperm. So, because of the characteristic golden color, the name assumes golden rice. Now, what is the science behind golden rice? Why rice was chosen for this kind of transfer of this trait? If you look at the rice germplasm, there's not even a single variety which has beta carotene synthesis gene. And in case of conventional breeding, we cannot. We have by screening and conventional breeding methods, we cannot able to transfer the trait of golden rice. So the only option is to go to genetic engineering tools. Now, if you look at how the technology evolved, way back in 1990s, Professor Ingo Porticus from ETH Zurich, Switzerland, he was the pioneer in starting this program. Initially, he thought that he was doing some work on some beta carotene, and then he got the idea that how we can use this technology to produce beta carotene in a rice endosperm, which is a staple food of more than half of the population around the world. So he tried to look for the genes, and then he found that there are 3 genes. 2 genes have come from daffodils. He isolated these genes from daffodil, and there's one more organism, Erwinia,